Hello everyone, Marhaba. My name is Titus Fidelis Tumbama. I'm a master's student in the Department of Architecture at Oka University, Istanbul, originally from Nigeria, where I completed my undergraduate degree at Federal University of Technology, Yola, in Adamawa State. It is a true privilege to present this article today as part of my submission for Act 502. I would like to express my sincere gratitude to my course lecturer, Professor Dr. Halil Sami El Yildiz, for his invaluable contribution, guidance, and for providing the opportunity to create these recordings. The topic of my presentation is redefining verticality for a sustainable urban future using timber for high-rise building. Hello everyone. My presentation topic, redefining verticality for a sustainable urban future using timber for high-rise building. What I'm trying to say here, I'm I'm researching on how I will design a structure of more than 25 to 100 story building that I can use wood, which is timber, to construct it. From the research idea, it gives me different types of ideas such as the systematic, technical, comparative, synthesis, and critical evaluation. This simply means to combine mass timber to a building envelope, which is building integrated photovoltaic that can be used to replace a concrete as the sustainable default for high-rise building in growing cities as such as Amsterdam, Italy, China. All they use it on the facade. The mass, but the mass timbers material structural analysis as one of my key findings. One, we have cross-laminated board, which is CLT, glue-laminated timber, glue lam, then laminated veneer lumber. From all timbers, mixed carbon benefit full biophilic interior, no concrete penalty. From cross-laminated timber, it is used as a comprehensive building material used to create walls, roof slab using timber, floors, then shear element and other part of the building. Glue laminated timber, it is used to create the bending and the spans, which is continuous line on the building structures, used as column, beams on the roof trusses. They laminated veneer, high strength to weight ratio, precision, engineered minimal waste, use lintel header specialist beams. From the findings, fire safety, performance, and environmental superiority, fire safety no longer a barrier because we have some sacrificial sharing, encapsulation, performance-based engineering, concrete core, synergy. All this combined together as one of the environmental performance in our today's life, we have 80 to 94%, then 60 to 91% of lower GWP compared to equivalent steel frame. Summation 50%, 19,000 kg, one floor per week. This is simply means using timber per week, you can create or construct one floor per week by using a timber. On the other hand, all timbers are hybrid, building precedents, structured. All timbers are glulam trusses, hybrid, hybrid timber concrete, hybrid cross laminated plus glulam plus reinforced core. All timbers CLT are glulam. This integrates almost all the case study on Mojotanet, Hohoviano, Hassan Emeka, Sericulture. This they use PV to integrate as a building envelope and the facade. In Mojotanet, Bromandel, Norway, this simply shows the high-rise building timber. You can see this is almost 35 floors of timbers using a hybrid construction, concrete core, integrated mixed timber. You can see the floor plan showing residential and recreational area on the floor plan, and it have a different wings which are more sustainable than using concrete in our today's life. From ancient Milwaukee, USA, you can see how they use timber to construct a column, beams, slabs, and how the columns are formed by using rectangular, and you can see how they generate it, how they make it. That's why from this place I have the idea to design my own in my own country. After gathering different case studies, you can see how the facade on the design, how they integrate this building photovoltaic. From this circle turquoise, you can see how they make the staircase with the timbers, how almost 40 stories. You see how they make the section and the curtain walls on it. But on this case study, building integrated photovoltaic integration, the energy positive pairing, it integrates a photovoltaic that replaces a conventional cladding with the photovoltaic modules that generate electricity while serving as a building envelope, net zero additional footprint and architectural function. This simply means it instead of using blocks or any prefabricated materials on the building, you can use building integrated photovoltaic direct as one of the strongest sustainability, and it gives great achievements in our today's life. From the Amsterdam, Netherlands, you can see how they construct high-rise building using wood on the facade, You can see how they use a solar as one of the greatest building envelope in our today's life. You see the you see the detailing, you see the detailing and the section. You see how they integrate everything from Sydney, Australia. You see how they use the wood to create an ecological factor. You can from the rooftop how they arrange the flowers at the facade, how they incorporate the PV, it gives shelters and it's it's a great sustainable building materials. From Amsterdam, this is how they integrate building integrated photovoltaic. You can see the interior, how the assembly of the shear forces and the bending moment of wood, the column, the cotton walls, and the CLT deck. You can see the building envelope, the slander on it. This is how they integrate all the columns. These are the part of the columns we have. For now, we have four of them from the building envelopes. The ecological factors from this section, Bosco Vertical, Shanghai Tower, Bahrain Tower, they give shelters, especially the Bosco Vertical. It gives shelters on the facade of the building. You can see how it integrates the prefabricated material on the Bosco Vertical, Milan, Italy. See the section. You see how the ecological is integrated. This is the one of the function that we need to put at the back of our mind, making this is one of our greatest sustainability. From the Shanghai Tower. Shanghai Tower, they use prefabricated materials and to create a high-rise building. And you can see the other side, they use timber as one of the greatest sustainability. Bahrain Tower, Manama, Bahrain. This is how they integrate every construction details. You can see the 3D and the floor plan. Yeah, comparison metrics. These are the comparison metrics of all the case studies, such as Mujitani, Hoviano, Sarah Kaltehos, and Center as of Netherlands, Bosco, Shanghai, Gerhane. These are the comparative metrics. Redefining the verticality, we have three pillars such as ecological, energy renewable, generation, urban sustainability. The convergence of mass timber that integrate as biophilic design is help to reshape us in architecture. Verticality is no longer defined by height alone, it is defined by ecological energy. Structural parts, translating research into architectural design, how to integrate. We have the structural strategy, building integrated photovoltaic energy, biophilic, ecological, circular, which it helps us to combine all our ideas together so that it can help us meet our demands. From this From this are my design proposal that I will try and bring it to my own country, Nigeria. You can see the map of Nigeria. You can see the FCT, how I cut it. You can see the topography. You can see the site plan, how I cut it from central business district in Abuja. You can see how the solar has been integrated on the facade and the rooftop. You can see from the section cut from the high-rise building. Design of timber high-rise building in Central Business District, Abuja. It gives me a strong momentum and great ideas to design to my country so that we can use it to maintain as one of the mixed use and commercial, like how the other countries, based on my own research, will do. You can you can see the generation, how I got my concept from the timber. You can see the design of the timber from the back to side to the cambium. You can see the wavy side plan and the rounded side plan, how I create my own initiative. You can see the ground floor, the other part, the other part, it is the residential area, while the other is commercial. That's why I'm designing a mixed-use building, while the other underground basement, where I'm using it for the parking space area. That instead of parking outside, I'm trying to control the carbon emission in our environment. Let's go back to the site plan. From the site plan, you can see we have the recreational area. We have where ambulance can park, taxis can park, children can play, water area, and every sustainable and recreational is bounded and embedded together. This as my site plan and my sections, 3Ds. You can see the interiors, how it shows the ecological buildings. These are my detailing. From detailing how it shows the cross laminated board, how I cut the section on the cotton wall, section YY, from the ground floor, generate my areas. This proof, on the conclusion part, this proof what it enables. Mass timber is structural variable for buildings. Cross-laminated glone and hybrid systems support building exceeding almost 180 meter fire safety. Integrating building integrated photovoltaic timber concrete energy, positive building, combining timbers and carbon separation. Environmental advantage empirically confirmed. The design integrates all three pillars. Mass timbers offers technically feasible, environmental superior, and economic competition pathway toward a resilient, low-carbon, human-centered cities of today's futures. That's why we are maintaining, instead of using a prefabricated area, we are using timbers to incorporate all our materials to develop or build or create or construct a high-rise building part of my recommendation, evidence-based for sustainable high-rise development, through the biophilic design, maximize building integrated photovoltaic, high-rise performance envelope, smart BMS occupant engagement, water sustainability, circular construction. This simply means integrating all the 6 recommendations to develop a high-rise and sustainable building environment to our systems today.
See you next. Thank you for your time. Thank you for listening. I really appreciate